Assalamualaikum warahmatullahi wabarakatuh. In this video, we are going to learn about Chapter 8, System Implementation. This chapter is about managing system implementation, which involve application development, testing, documentation, training, and data conversion and system changeover. Alright. Okay, as usual, before we start, I will recap software development life cycle phases. Alright. As you can see in this diagram, you are now in a phase 4, okay, system implementation, and you have done cover phase 1, system planning, which is chapter 2, analyzing the business case. Phase 2, system analysis, which cover 3 chapters: requirement modeling, enterprise modeling, and development strategy, chapter 3, 4, 5. And phase 3, system design, which cover chapter 6 and chapter 7. And now in phase 4, you are going to learn chapter 8. Alright? Okay, fourth phase of software development life cycle will include application development, testing, installation, and evaluation. So users will be working with the system on the day-to-day basis, and you will focus on the system operation and support, which is the final phase of software development life cycle. Okay? Okay, when you finish this chapter, you are supposed to be able to explain the importance of software quality assurance. Alright, you know how to describe the application development using structured method. Okay, you can explain the coding process and unit testing the system. Okay, you know how to differentiate between program, system, operation, and user documentation. You know how to develop training plans for various users groups, and you can describe data conversion and change over methods. All right. So during the system implementation, the system design specification serves as a blueprint for constructing the new system. Okay. The initial task is application development, which requires system analysts and programmers to work together to construct the necessary programs and code modules. Okay. Before a changeover, the system must be tested and documented carefully, and user must be trained and existing data must be converted. All right. Okay, after a new system is operational, a formal evaluation of the results will take place as a part of final report to management. Okay, software quality assurance. In today's competitive business environment, companies are intensely concerned with the quality of their products and services. Okay, so rigorous testing catches errors in the implementation stage, but it is much less expensive to correct mistakes earlier in the development process. Okay, the main objective of quality assurance is to avoid problems or detect them as soon as possible. Okay, basically, the poor quality can result from inaccurate requirements, all right, design problems, coding errors, faulty documentation, or ineffective testing. All right. So, in order to improve the finished product, system developers should consider software engineering and internationally recognize the quality standard. All right. So, I have attached additional video about software development life cycle with specific focus on the software quality assurance and testing phase. I hope you can watch that video, right? So next, we move to software engineering. Okay, as I mentioned in the previous slide, the main objective of quality assurance is to avoid problems or to detect them as soon as possible, right? So, in order to improve the finished product, system developers should consider a software engineering and recognize a quality standard. Okay, so software engineering is a software development process that stresses solid design, accurate documentation, and careful testing. Okay, it is basically used to manage and improve the quality of the finished system. The Software Engineering Institute at Carnegie Mellon University is a leader in software engineering, okay, that provides quality standards and suggested procedures for software developers and system analysts. Okay, SEI have designed a set of software development standards called Capability Maturity Model, uh, which is the purpose of this CMM is to improve software quality, reduce development time, and cut costs. Right? Okay, now International Organization for Standardization. It is a worldwide body that establishes quality standards for products and services. Okay, in 1991, ISO established a set of guidelines called ISO 90003, which provided a quality assurance framework for developing and maintaining software. Okay, so ISO requires a specific development plan, which outlines a step-by-step process for transforming user requirements into a finished product. Okay, okay, in software quality assurance, for example, SIO requires software supplier document all testing and maintain records of test result. Okay, uh, okay. If problems are found, they must resolve, and any modules affected must be retested. And a software and hardware specification of all test equipment must be documented and included in the test records. Okay, that's how um, we implement the ISO quality standard. All right. Okay, application development is the process of constructing the programs and code modules that are the building blocks of the information system. All right. If you remember, in chapter 1, you have learned structured analysis and object-oriented analysis methods for system development, right? So the objective of those methods is to translate the design into program and code modules that will function properly. Okay, so your first step in application development is to review carefully all existing documents in system design. Okay, so I mean system design phase, right? Okay, the example of your documentation is the system design specification accompanied by diagrams, source documents, screen layouts, report designs, data dictionary entries, and user comments. Okay, if you look at this figure, it is shows about building a new system, and it requires careful planning. Okay, okay. After overall strategy is established, okay, individual modules must be designed, coded, tested, and documented. Okay, after the modules are developed and tested individually, okay, this one, more testing takes place. Okay, along with through documentation of the entire system. Right. So that's how the application development process. Right. Okay. Next, documentation review. Basically, you will need solid documentation from prior SDLC phases to design program and code modules. Alright, so using the system documentation as a blueprint, you will develop structure charts uh, that break the system into smaller pieces that programmers can translate into programs and module. Okay, basically at this stage, you should already know what is modules. Alright? Okay, Module will consist a related program code organized into small units that are easy to understand and maintain. Okay. Okay, when you create program modules using structured method, you must start by reviewing documentation from SDLC phases and creating a set of program designs. Okay. In program design, you must view the system as a series of interactive modules, right? Uh, Structured application development usually involves a top-down approach, which is proceeds from a general design to a detailed structure. Okay, and normally after a system analyst documents the system requirements, he or she will break the system down into subsystems and modules. Okay, this process is called partitioning, and sometimes this approach also called modular design. Right. So in application development, all the process will use project management software. Okay, next is structure charts. Um, Structured development basically relies heavily on data flow diagrams and structure chart, right? Okay, structure chart show the program modules and the relationships among them. Okay, it consists of rectangles that represent the program modules with arrows and other symbols that provide additional information. All right. Um, Typically, a control module will referring to a higher level module, and subordinate modules is referring to direct lower level modules. Okay. Okay. In structure chart, symbols represent various actions or condition. Okay. A structure chart symbol represent a module, data couple, control couple, condition, and loops. Okay. Look at this figure. Okay, a rectangle represent a module. Okay, a vertical line at the edge of a rectangle indicates that the module is a reusable code and can be invoked from more than one point in the chart. Okay, so next is a data couple. Data couple shows data that one module passes to another. Okay, for example, in chart, an arrow with an empty circle represents a data couple, like this. Okay. Okay, now is a control couple. Uh, a control couple shows a message which one module sends to another. It is also called a status flag. Okay, basically an arrow with filled circle represent a control couple. This one. Okay. So a module use a flag to signal a specific condition or action to another module, right? Okay, I have also attached another video regarding structure charts. Okay, uh, please again watch the video for your additional knowledge, right? Okay, next is structure chart symbols for conditions and loops, right? Uh, a line with a diamond on one end represent a condition. This one. Okay, a condition line indicates that a control module determines which subordinate modules will be invoked depending on a specific condition, right? Okay, loop indicates that one or more modules are repeated. Okay, a curve, this one, a curved arrow represents a loop. Okay, in this figure, uh, a get student and calculate GPA modules are repeated. Alright. Okay, cohesion and coupling are important tools for evaluating the overall design. right? If you need to make a module more cohesive, you can split it into separate units, each of which performs a single function, right? Basically, a cohesive module is much easier to code and reuse. Okay. Okay. Coupling describes the degree of interdependence among modules. Okay. Basically, modules that are independent are called loosely coupled. Okay. Uh, Loosely coupled are easier to maintain and modify because the logic in one module does not affect other modules, right? So if programmer needs to update a loosely coupled module, he or she can accomplish the task in a single location, all right? If modules are tightly coupled, one module is linked to internal logic contained in another module. So for that reason, passing a status flag down as a message from a control module is generally regarded as poor design. Right? It is better to have subordinate modules handling processing tasks as independently as possible to avoid a cascade effect of logic errors in the control module. Okay? Okay, these are the steps in drawing a structure chart. Okay, basically, structure charts will be based on the data flow diagrams created during data and process modeling. Okay, so you must review the FDs to identify the process and methods. Okay, you must identify the program modules and determine control subordinates relationships. Okay, add symbols for couples and loops, and analyze the structure chart to ensure that it is consistent with your system documentation. Okay, so typically, structure chart will follow 4 steps. Okay, your first step is to review all the FDs for accuracy and completeness, especially if changes have occurred since the system's analysis phase. Okay. If object models also were developed, you should analyze them to identify the objects, the methods that each object must perform, and the relationships among the object. Okay. Okay. Step 2: identify modules and relationships. Basically, you will work your way down from the context diagram to the lower level diagrams. Okay, you have to identify control modules and subordinate modules until you reach functional primitive. Okay, basically, if more cohesion is desired, you can divide processes into small modules that handle a single task. All right. Okay, step 3, uh, add couples, loops, and conditions. You can review the data flows and the data dictionary to identify the data elements that pass from one module to another. Okay, the last step is step 4. Uh, Analyze the structure chart, the DFDs, and the data dictionary. Okay, at this stage, the structure chart is ready for careful analysis, right? You should check each process, data elements, or object method to ensure that the chart reflects all previous documentation and the logic is correct. Okay. Um, you should also determine that modules are strongly cohesive and loosely coupled. Okay. Uh, Normally, at this step, you must draw several versions of chart, right? Okay, other application development tools are program flowchart and pseudocode. Okay, a flowchart represent a logical rules and interaction graphically. okay, using a series of symbols connected by arrow. Okay, using flowcharts, programmers can break large systems into subsystems and modules that are easier to understand and code. All right. Okay, next is a pseudocode. Pseudocode is a technique for representing program logic. Okay. Uh, Pseudocode is not language specific, so you can use it to describe a software module in plain English without requiring strict syntax rules. Okay, by using pseudocode, normally system analyst or programmer can describe a program or actions that can be implemented in any programming language, right? I also attach the video regarding the how to convert pseudocode into a structure chart, and the other way around, how to structure chart convert to pseudocode. You can watch the additional video for your knowledge, right? I think it's all for the chapter 8. Assalamualaikum warahmatullahi wabarakatuh. Thank you.